So, to address the disadvantages of RNNs, LSTMs, and other recurrent neural networks, there was a new variation created called as the transformers, which becomes the foundation to many of the large language models that we see today. Now, to solve the issues of the RNNs, a bunch of people came up with a concept called as attention. And this is very, very fundamental to how transformers work. So, if we were to simplify what this attention means, so attention is a technique that created the transformers, and many times there are certain parts of sentences that are more important. For example, if you were to see a sentence which had a word called gold, now that might be more important than the word the in that sentence. So attention allows to focus in on those parts such as these uncommon words like gold and names, and they do that by assigning weights and scores to each of these words. Now transformers are a kind of neural networks with attention on top to give more context. So that is what transformers are. It's nothing but a neural network with attention on top of it. And what attention is, we just saw. So transformers benefit over the RNN is that it scales efficiently to large data set, mainly because it's very easy to parallelize or make use of multiple cores of the computer. And they have better contextual learning because of the concept of attention. And this attention creates weighted relationships between words. And we still use encoder and decoder similar to LSTMs and RNNs, but what is inside of these encoder and decoder are significantly different from what we saw in the past. So let's take a quick example over here. So we have a sentence called giving machines the ability to understand natural language. Now, in a sequential manner, you would just go about looking at just one previous word or two previous words in RNNs and then try to predict the current word or the next word in the sentence. But here is where it gets different when we look at the transformers, which have attention or a lot of context on top of this, where we're not just looking at one single word on its own, but we are actually mapping all the words with all the other words within this text. And this is how the map would look like. And it's not just these lines, but they're also given different weights so that a word like machine might have more information or more importance in a given sentence than this word just the or to or some other very common words. So there is a good visual representation of how all this works, and I've put a link over here. So when we come to this visualization, there are few parts. There is the head view, there is the model view, and there is also the neuron view. But we don't have to worry too much about trying to understand all this yet. All we want to do is try to understand how this attention is working. And if I just hover my mouse over all of this, you can see the lines going to the words on the right side over here, which not only just points to the word, but it also has different intensity of lines as well. So here it's a bit more obvious where the bottom line and the top line have a bit more width compared to the other words in the middle. So this is how we're not just looking at one single word on its own, but we're actually looking at and mapping all the different words. Now, if you come in here and look at the model view, you'll be able to see all these variations or permutation combination of all this. So from all this visualization, all we can understand is with attention, we are not only looking at just the previous word, but we have the entire context of the input that has been given to the model.